Hello, my name is David Brooks, a security sales engineer here at Vectra AI. Vectra is a threat detection and response platform which aims to leverage machine learning and artificial intelligence to surface attacker patterns, enterprise networks, and cloud deployments, with the goal of reducing risk. Today, I'd like to speak briefly about the recent Log4J vulnerability that's been causing chaos over the past week or so, along with its implications towards the enterprise's detection strategy as a whole. By now, there's a lot of information out there about this vulnerability and what it does. But in summary, Log4j is a logging utility based on Java. It's a common component of web-facing applications, and it's in wide deployment globally. Log4j was discovered to have a vulnerability which allows unauthenticated remote code execution, basically allowing an attacker to gain control of the targeted system. So I'm going to walk through a very brief demonstration of how the vulnerability itself works, how systems targeted with this vulnerability can be detected, leveraging things like network metadata, and what the bigger picture looks like, and where we go from here. So what I'm showing on my screen is two terminal windows. On the left side here, I have my attacker system. This is going to be setting up the LDAP listener and actually running the exploit. We can see that my goal here is to query the vulnerable application running on the victim machine, and I'm going to touch a file on that machine called temp ho ho ho. Over here on the right side, I've got my vulnerable application running in a Docker container here. If I go ahead and I list the contents of the temp directory in that container, I can see that I just see just the normal stuff I expect to see in a temp folder. Nothing here that's temp ho ho ho, but if I go ahead and run my exploit, which by the way was provided by someone named Cyberstruggle over on GitHub, made a very easy to use and approachable exploit, very considerate. It's already done. And if I go look at the contents of that directory again, I can see that I've got my ho 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 file created, right? Obviously, it should go without saying that if I can manipulate files remotely, or I can execute arbitrary commands completely unchallenged, we have a problem, right? And really the scope is limited to my creativity as an attacker. Like, what am I going to do with this? Am I going to delete files, modify logs? Am I going to establish C2? All kinds of things I could do with this as an attacker, right? So obviously a pretty big problem. What does it look like to detect? How do we detect this on a network? Well, I mean, a couple things we can do. There's already lots of information out there about callback IP addresses that have been identified for attack campaigns. Of course, we could go and look for any communication from my network to those identified IP addresses, host names. Pretty simple. I mean, like lots of things will do that for you. A firewall, threat intel. I mean, you could use all kinds of sources to find that. I could use this here to find this. I could also look for strings that appear within the metadata itself. So here I'm looking for J and DI and a smattering of other things that appear in an HTTP connection, which might be a little bit concerning. I could look for things like outbound LDAP communication, which of any sort would be a little bit concerning. So that would be something I could look for. But here I have an example of the command I just ran, right? The callback between my victim and my attacker machine. So I do manual hunting here. I go in here and I find all the things manually that are matching my query, right? So it takes someone's time to go through here and find this. But I could also use Vectra's detect platform and just take the work out of it. I could say, hey, I've made this query against my metadata. I'm going to turn that into a custom model, and I'm just going to sit back and let this tell me when I see matches against that, right? So now I'm doing no work. I'm just sitting here and waiting for it to tell me, and from there I can take an enforcement action against that host, or I could flag it for follow-up and further investigation, whatever my process happened to look like, right? So a couple ways we can see this and do with this, either in a proactive hunting type scenario or leveraging metadata to find it on a network, or I could trigger that automatically and sit back and wait for the results to come to me. So let's put this together a little bit. What does this actually mean from the standpoint of an organization? Well, I think the first thing that we need to think about is that, on its own, Log4Shell, Log4j vulnerability, whatever we're calling it, by itself is not the problem, right? That's not the issue. That's going to be a component of a larger issue. An attacker is going to use this as a tool in their bag to do other things that they've always done. Case in point, we've already seen this, pretty early on after the vulnerability was made public. We started seeing the things we'd expect to see. It's being used against vulnerable web applications to install things like crypto miners, to use those resources, for DDoS, all the things that we expect. And these are problems. Like, an organization has to address these things. This is expensive, it takes time. So certainly we've got to protect ourselves against these types of things. But, more concerningly, we have groups like ransomware groups like Conti. They're actively now using this as part of their playbook. So if they have a foothold in your organization, they're now going to start using Log4j, Log4Shell to accomplish their goals. Now that might be upfront, where we're using that to establish initial C2, or it might be, in this case, part of a lateral movement strategy where I'm targeting a vulnerable vCenter app with the exploit, installing Cobalt Strike beacons and eventually monetizing your data, right? So we're seeing this in use now by an advanced attacker group. Where does it go from there? Well, I don't know. Exploits and attacks, they always evolve. We could do any number of things after we have a foothold in your network, whether that was with Log4j or something else, right? We're going to go through these motions as an attacker. We're going to establish C2. We're going to perform recon. We're going to get sticky. We're going to move laterally. We're going to escalate privileges, identify data, figure out how to monetize it, either exploit it, or exfiltrate it, whatever we're doing. So lots of things. Case in point, Eternal Blue, it's still out there. It's still being used to move laterally. It was from like 6 years ago now. It's very easy to detect, but it's still a problem, right? We've got to have some solution to be able to identify these broad behaviors that attackers are engaged in. So let's think through that. What can we do to help us through that process? Well, first, a SOC has to be able to identify these things as they happen on their network. Things like external vendors, IoT, they're making it so this never really goes away. This is going to be with us for a while. It's going to take time to patch all these vulnerable systems. And even if we do patch everything on my network, someone can come in, external party that's still vulnerable. I mean, there's all kinds of reasons why this is not going to be quick. So you've got to be able to understand and identify these attacks as they happen and stop them before the end goal occurs, right? So consider that advanced attacker playbook we just looked at from Conti, right? We're looking at all the way through command and control, recon, lateral movement, whatever comes next, right? These are broad behaviors that, Vectra security-led AI helps a team identify quicker, all the way through that playbook. These broad behaviors generally don't change. As an attacker, I'm going to do recon. I'm going to establish C2. The method by which I do it might change, right? My C2 might be established by Log4j in this case, or my recon might be done with Nessus or Interpreter module, but the broad behavior is still there. That's not changing. So we've got to be able to allow a SOC to clearly prioritize these threats, hopefully faster than they can today, which provides significant risk reduction by reducing the window that an attacker has to reach that end goal. That's all I really have today. I really appreciate you giving me a few minutes out of your day, which I know in December is kind of a tough ask. Hope you learned something new. I've learned something new as I've been educating myself on this, and I hope to speak with you soon. Thank you so much.